Welcome to AP Computer Science, Java, Programming. We are in Chapter 9, Section 9, and this section is talking about arrays and methods. Arrays and methods. So hopefully you remember what arrays are, and hopefully you remember what a method is. And so what we're going to be doing is talking about how those two things interact together. So you could obviously use methods to process arrays. And so how does that work and how does that look like? Now before we dive into this, we're actually going to have to review a little bit. And so, hang on. There's a couple of, I've typed up a bunch of notes directly from the book and some of my own things. And so we will not need the book today. I will just go directly off of my notes here. All right, so the first important point to review before we dive into arrays with methods is when primitive data types, so think ints, doubles, and there's other ones, right, that we don't really use too often, but like char and boolean and things like that. So when primitive data types are passed to a method, a copy of the value is passed. Changing the copy does not change the original. Okay, so that's with primitive non-reference types. So we're not talking about objects, which are reference types. We're talking about primitive data types. When you pass something to a method, one of those to a method, the copy is passed, not the actual item. Okay, so if you change it within that method, it does not affect the original. So let's take a look at an example. Okay, so we have a variable of type integer. Well, let's go ahead and what's called original, and it's set to the value 5 at the beginning. And so then we pass it to we go ahead and call on a method called doAction. And see, we pass it along. We pass it along to it. So calls the method doAction and passes it a copy of the value stored in the variable called original. So the number 5, a copy of that number 5 is passed on to it. And so that is the client code. Right here is the client code. Let's take a look at the server code. What actually happens? So here's the server code for the doAction that we just called on. And look, it is expecting to receive an integer. So that 5 that was passed gets caught into this temporary variable called parameter. It holds on to that 5 inside this temporary variable. And so we go ahead and modify parameter. We say, you know what, let's add another 5 to it. So parameter equals itself plus 5. So now the value of parameter at this point, after we execute this, should be 10. And in fact it is. After this method is run, the value of the variable original is still 5. Well, why? Well, again, this is just all review, because this is just passing a copy. Every time you're dealing with primitive data types like integers, you're dealing with a copy. Okay, so that's just a review. So important point number 2, when objects, say strings, arrays, students, right? All objects are passed to a method. A reference, in other words, a bookmark to that object is passed instead of the entire object itself. Just the bookmark, the reference to it is passed. Because it's just the reference to it, changing the object while inside a method will change the actual object itself. Okay? It will, because you're changing the bookmark, it will actually change the actual thing itself. So before I move on to example, the analogy I like to use is a check, right? I mean, a lot of people these days don't use check. They use debit cards or credit cards, right? But let's pretend you had a check. Let's pretend I wrote you a check for $100. Now, is that actually $100? Is that actually physically a $100 bill? No. But it's just a reference or a bookmark to real cash. And so if I wrote that check out to you and handed it to you, even though that's not actually it's not actually the real object itself, it's a reference to it. If you cash that, will that really affect my bank account? Well, you bet it will. It will affect how much money I have in my bank account. It will, in fact, change my actual real bank account. So that's what objects are like, right? And so think of a check, right? So that's the way it works. The object is a reference to the real object, and so passing along the reference to it will actually eventually affect the original. So let's take a look at an example. So let's look at the client code first. I make myself an array of integers, and inside there I have 1, 2, 3, and 4. So there's just 4 items, 4 numbers in my array, and they're all integers. I call on some mystery method called increment array. I pass it my array, which has the 1, 2, 3, 4 in it. Now technically I'm just passing the reference to it, the bookmark to it, right? And I pass it a number 3 for some reason. Now it could be any number, as you'll see later, but I just pass it some random thing, because really what this thing's going to do is it's going to change my actual array. So this is the client code right here. Let's take a look at the server code. What actually happens in the server code? Well, here it is, the server code right here. So I have increment array. It gives you back nothing. It returns nothing. It catches an array of integers and gives it the temporary name of abc. It catches an integer that you give it and gives it the name number. So the 3 goes in there, and my array called 1 with 1, 2, 3, 4 goes inside of here. All right. Take a minute to look at this loop right here and see if you can figure out yourself what's going on. Go ahead and pause the video if you need time to look at it, because I'm going to pretend you pause it, and I'm going to give you the answer right now. All right, so what's going on here is it's going to go from the first element to the last element in the array, going one step at a time. And each time, whatever is in there, so at spot 0, at spot position 0, there's a 1 in there. Well, I'm going to go ahead and add on to itself whatever you pass me, which is a 3. Oh, okay, I'm going to add 3 to it. And then I'm going to increment, and I'm going to do that same thing with the next one. Add 3 to it, add 3 to the next one, and add 3 to the next one. The question is, that you should ask is, after I get out of doing this, does it affect the original array or not? Because it was caught as ABC. So you might think, well, it just affects ABC. It doesn't affect my array. Well, the thing is that, again, this is a reference. So the bookmark was sent. It was caught and given a nickname for it. But it's pointing to the same place. This thing is pointing to the same place in memory as this thing was. So after this method is run, the value of the array, my array, is going to be 4, 5, 6, 7. So yes, it does affect it. So anytime you're dealing with reference types, again, reference types are simply bookmarks. And that will affect, if you modify it, it will affect what really is there in memory. Even if you have another bookmark to the same page in the book, right? There's 2 bookmarks to the same place in the book. And what's on that page? 1, 2, 3, 4, and 5. 1, 2, 3, and 4. Okay. Methods to sum arrays of integers. So let's see if we can go ahead and add up excuse me, add up all of the numbers in an array, and we're going to create a method to do that. So let's take a look here. Oh, so this is a whole program here. All right, total is 0. My array, we go ahead and make space for up to 10 numbers in it of type integers. Let's say this is not important, but let's just say we fill it in with some random integers, whether we're prompting the user or getting a random number generator, right? We're filling it up with 10 random numbers. Okay. And total, which is currently 0, we're going to say that it's going to be equal to the sum of my array. Ooh, so I'm calling on a method, and that method is going to receive this array that is now filled. And so it's going to do its job. It's going to pass back, hopefully, an integer, and that will be stored inside total. And I'm just going to go ahead and print out total. Sum of all elements in array. Ooh, I spelled array wrong. Array. Array is, and I print out total. All right, so this is the client code right here. Let's take a look at the server code and see what's going on. How does this thing tick? What makes it tick? Well, let's take a look. Here's the server code. Public static int sum. Oh, so you can see that this is the return type is an integer. It's going to hand back an integer. Good thing, because this thing's expecting to catch an integer, because this is a type int, right? Okay. All right, and you pass it catches an integer of array, and it nicknames it. Whatever you pass it, it's going to re-nickname that bookmark as A. All right, we passed it my array, and it's going to be nicknamed A inside of here. All right, we have a running total that we're going to start called results, and obviously we're going to start out at 0. Ooh, and we're using, hopefully you still remember, we just learned this last time, an enhanced for loop, which again processes from the first element to the last element in order, never skipping anything. It goes ahead and grabs whatever is inside each box, each mailbox. It grabs that because it's going to hold it inside of the temporary variable that you declare here. We called it int element, processing through our array, which is nicknamed A. And every time through, we're just going to take whatever was in that box at that place and add it on to result, and then go to the next one, and then add it on to the results, and etc., etc. And eventually, I return results. Okay, so when you return something, you need to catch it, and we did right here. We caught it inside of total, and so it's going to print out the total. The sum of all elements in the array is, and whatever that number happened to have been. Okay, so hopefully you understand this code here. This is a very, very simple example to add up all of the elements inside an array by calling on a method. Well, Ms. Yang, why did we have to call on a method? Couldn't we have just, right here in our client code, couldn't we have just gone ahead and used a for loop or an enhanced for loop right there to do it? Yes. But obviously, you can imagine situations in the real world where you might have to do this more than one time. You might have to do this on demand. And so putting this inside, the ability to add up every element inside of a method, is a better solution than going ahead and rewriting this code every time you need it, right? Especially if you're expecting to do this more than once, then go ahead, throw it inside of a method, call on that method on demand anytime you need it. Does that make sense? Hopefully. All right. So that's a simple example of calling on a method and that method being able to process an array. All right. This method will work for arrays of any size. Any size. So ours happened to have been a size 10, but if we sent it a size 100 or a size 1,000, it would have worked perfectly because we used an enhanced for loop and all of that is automatically taken care of for us. Now, it will only work as long as the array is full and is of type int, right? So because it is processing integers, we're assuming that it's processing integers, and we're assuming that the array is full. If it is not full, then we're going to have to, number one, we can't use enhanced for loops, and then we're going to have to track, remember, logical size and physical size. Logical size and physical size, which we learned earlier. All right, let's see here. Application. Writing methods that process arrays can help us search, sort, or compare arrays. Right? What if you have to search over and over again arrays for a certain number? Well, if you have to do that more than just one time, probably want to put it inside of a method. What if we want to process, like we just did? Or we want to sort, rearrange some of them, right? So any of these cases would be a good candidate for actually putting it inside of a method that you can call on demand as many times as you need, as opposed to statically writing it exactly in the place that you need it every time in your client code. All right, let me take a look. I haven't seen these notes for a while, so let's see what's going on here. I have two arrays, this one and this one, array number 1 and array number 2. Let's see what's going on here. Okay, I mean, yeah, I guess you could do this. I don't know why you'd want to, but I guess there could be a use case for this. Using this method that we just looked at, the summing all of them, we could go ahead and sum array 1 and sum array 2 and then compare them, which would be equivalent to saying if 227 is greater than 60,553. Okay, so I guess that would be an application there. Now, a lot of students might do something like this. Is array 1 less than or greater than or even equal to, right? Array 2. This is wrong. You cannot compare arrays like this. These are just objects, or more accurately, these are just bookmarks to objects. So you cannot compare them. Whereas if you threw it inside of something, you process it through a method, then then you might be able to go ahead and actually do some comparison between two arrays. But here, they're just bookmarks. You can't compare them. Okay. Example number 2. Search for a value and return its location. So we have an array full of some numbers, like, for example, like that, right? And we want to search through it, and not only do we want to see if it's there, but we want to find out where it is. So let's say we're looking for the number 89, right? We don't want to just know, is it there or is it not there? Is it absent or is it present? But we actually want to know what index is it found at. Because, again, this is a very unrealistic example. You might have an array of hundreds or thousands of items, right? So you want to not just know, is it there? I want to know, where is it? Because I want to change that number or modify it in some way, right? So in this case, 0, 1, 2, 3, 4, 5. It is at index 5. The 89 is at index 5. So let's take a look at an example of how we could do that using a method. All right. So take a minute, pause the video, and take a look at that. Okay, hopefully you paused it and took a look. This is called search. It's of type int, so it's going to give us back an integer. Because that's the index where you found it is obviously going to be an integer. Okay, it's expecting to receive from the client an array of type integers and an integer that you're actually looking for, so like 89. All right, we have a for loop that goes through the entire thing. And if the current element at the current index is equal to whatever number you're searching for, let's say 89, go ahead and return whatever index you happen to be on at that moment. Hopefully that makes sense. So far, so good. Now, obviously, if it's never found, look what happens. Return -1. We have two return statements. Remember, return statements, the first one you encounter, you exit, you do the return, and then you're out of the method. You're exited out, you're back to the client, you're out of the server. So there are two, but obviously whichever one process it happens first is the one that actually kicks you out of and goes back to the client. So what's going on here, I hope you understand, is obviously if nothing was ever found, it's going to actually return a -1, which is a flag to signal that nothing was found at all, because obviously -1 is not a valid index in your array. So that's a signal that it didn't find anything at all. Okay, so the question you should be asking yourself right now is, why didn't we use an enhanced for loop right here? Wouldn't that have made life a lot easier? We did it in the previous example to sum all the elements together. Why not use an enhanced for loop here? Let me see, did I write an answer? Nope, I didn't even write an answer. So let me just answer you right now. Because we're dealing with indexing. Remember, enhanced for loops, it takes care of everything for you. It streamlines everything. But remember, it's always going to process from a first to last, never skip anything, and does not use any indexing at all, which means if you need to remember what index you found something at, you're out of luck. No indexing, no I, no nothing. Well, I need the index. Well, then you're going to need to use a regular for loop instead of a enhanced for loop. That's why we had to use a regular for loop right here, because the index actually mattered. Okay. Let me see here. Oh, I suppose. Oh, I see. Here's a real life usage. So, here is the server code. Let's take a look at what I would actually do in the client code to take advantage and actually use this. So, int index, int number looking for is 54. I mean, you could have prompted the user for a number, but let's just say we're looking for 54, and I'm going to hard code it to 54, darn it. Okay. Then I go ahead and I'm going to catch whatever index you found it at, if you found it at all, at... Ooh, see, look at this. I'm going to go ahead and call on my method called search, pass it my array called sumRay, and pass it my 54. Okay, so then it's going to hopefully give me an index. I'm going to catch back whatever it hands me back, which is going to be the index it found it at. Or if it didn't find it, it's going to give me back the -1. So look. I'm just going to say, excuse me, if the index is at -1, that means you did not find that number. So I'm going to go ahead and print 54 not found, right? Because the variable num looking for, right, is 54, right? Otherwise, if it's not -1, it means that, ooh, this happened. It actually returned a non-1 number, a number that was not number -1, which means that the flag was tripped. That means 54 found that index, and I print out the index. So that is a client. That's the client side of this usage here of the server. Okay. Example number 3 is summing the rows. We are going to now pass this guy a 2-dimensional array, and we just want to add up, we want to know the sum of each row. So obviously, to enable to do that, you're going to need to hold on to multiple integers because you have many rows. And obviously, instead of having multiple integers, you're going to have to then return a 1D array, because remember, you can only return one item, whether it's one integer or one array or one 2-dimensional array. So there's no way you can have like 10 integers and return them unless you use a 1D array to do it. Okay, so let's take a look. This is the server code, which is called sumrowsMethod. And look, you pass this guy a 2-dimensional array. It gives you back a 1D array. Okay, so right here we're gonna, we create. Okay, this, don't gloss over too quickly because there's a lot of magic happening here. First of all, we're just like before when we created, hang on, sorry, I hate to move things on you, but for example, in this method here, we needed to create a temporary variable to be able to hold on to data. In this case, we passed it a 1D array, so we just need to hold on to one integer as a temporary thing. But since this thing here is holding, you're giving it a 2D array, the temporary variable itself is a 1D array. And how long should I make that 1D array? Well, let's go ahead and make it the length of the 2D array, because the length of that is going to be the length of each row. Okay, so lots of things are kind of going by really fast. So if you need to ever pause and contemplate, definitely pause and contemplate. And you can also look at the book, right? The book will, I mean, these examples here are pretty much directly from the book, but the book also explains it in its own words, so maybe that can be helpful as well. Okay, so we have my comments here. Create a new temporary 1D array of same length as the array ABC, which is your 2D array. So that's what's going on there. Okay, now here is the for loop. Let me just skip to the rest of it. Take a minute to look at that and see if you understand what's going on. Pause the video because I'm just going to jump right in. Okay, so we're processing the 2D array. So obviously with a 2D array, you need a 2-dimensional for loop. There it is. And I already taught you why we're doing this and why we're doing that. All right. And our temporary variable, which is a 1D array, is going to go ahead and grab the item in that row of the 2D, the first item, because we're starting at 0. The first item of that row of that 2D array. And then it's going to grab the second item, and then the third item, and the fourth item, and the fifth item. And eventually it's going to jump to the next row and then do that as well. And then it's going to jump to the next row. And after it finishes all the rows, all the data should be inside this 1D array. So my comments, add sum of each row from array ABC, which is your 2D one, and store it in array rowsum, which is your 1D array. And look here, we are going to return rowsum, which is an array of type integer. So we're returning that. So there is the client code right there. Hopefully that makes sense and you understand it. And hopefully you also, if I asked you to go ahead and write the client code for it, for this server code here, if I were to ask you to write the client code, you would be able to write it and make full use of this. If I were to give you a 2D array full of a bunch of numbers, you would be able to call on this guy, use it, and print out the sum of each of the rows. Here is the client code. Let's take a look. The usage in main, aka client code, is right here. Okay. Now, here's my 2D array. And obviously the first row, if we add 1 plus 6 plus 4, it's 11. 9 plus 3 plus 18, 20. 2 plus 7 plus 5 is 14. Okay? But this is actually how we would do this. Now, let me get back to this in just a second. But let me just, because that's kind of hard to understand for some students. But so let's just skip that for now. Let's get to the easy part first, right? So our 2D array, we went ahead and make our 2D array. We went ahead and made our 1D array, kind of, and I'm going to explain that later. And then we're going to go ahead and say equals the server code above, right, our method, which calls on sumrowsMethod, and we pass it this guy right here. And when it's done, I went and comment. I mean, we could have went ahead and called on a print statement to print out, but yeah, I made a comment. At the end of calling this thing, my 1D array will look like this: 11, 20, and 14. Okay. So here's the part where students sometimes mess up on. Well, it's not going to break anything. It's just unnecessary. So students will often do this. There. They will do something like that. And obviously we don't need that. I guess we just need a comment right there. Well, Ms. Jang, we are making a 1D array, and we use the keyword new, which means something's actually created. Because if you don't use the keyword new, nothing is actually created. And so, Ms. Jang, I'm pretty sure you're going to actually need it. Otherwise, you have a bookmark to nothing. So what's going on here? Well, yes. Yeah, we are actually making an object when you ever use the keyword new. And so, yes, memory, real memory is now being reserved. You're actually taking up space. And this bookmark is pointing to the area in memory where that space is now taking up, which has nothing in it. Would you agree? There's actually, it's taking up space in memory, but there's nothing in there yet. It has room for 3 integers, but it's not taking up any, it's taking up the space, but there's nothing there yet. Okay, let me Control-Z, Control-Z, Control-Z. You actually didn't need to do that. All you needed is the bookmark. Well, Ms. Shang, why? Because if you only have the bookmark, you don't actually create it. And so we're going to have a problem there, aren't we? Because you're right here, if you don't actually have any physical room and memory, and you're going to go ahead and catch whatever this thing returns, aren't you going to have a problem? You won't be able to catch it. Let's look at the server code one more time. Bam! Right there, we went ahead and created enough room in memory. We used the keyword new here. So there is something in memory being created and populated, mind you, right here. We're using for loops and we're throwing the sum of all of them together. So it's being created here, keyword new, and being populated right here, and being returned here. So this thing right here, rowsum, is pointing to this newly created thing we did inside of our server code. We created an actual place in memory and populated it in our server code, and that bookmark is now being returned. To who? To this guy here. So, what's going to happen is it's unnecessary. I know this is kind of a little bit confusing, but it's unnecessary to create space for it in memory here, because all that's going to do, what's going to happen is this one's not going to be populated with anything. It's going to get severed when you return this thing. It's going to overwrite it and say, hey, I know the bookmark was in this page of the book, but I'm yanking it out, and I'm going to stick you here in this other page in the book. So this thing here is just going to get lost, and eventually the Java garbage collector is just going to go ahead and say, oh, it's severed. Let's go ahead and clean it up and throw it away and erase that from memory because it's not being used at all. It's not being referenced. So why even create it if you're never going to modify anything in that place of memory, and it's eventually going to get severed anyways when this rowsum returns, right? This rowsum's method returns this guy here. So there's just no purpose of doing that at all. It's not going to break anything if you do this, but it's highly unnecessary. Okay, I hope that makes sense. That's kind of a high-level talk there. All right. Now comes for another high-level talk. Let's try copying an array. Now let me show you the wrong way and then the right way. The wrong way, then the right way. So and this wrong way, this is a move that a lot of rookies will make when they're trying to copy an array. So here's the premise. Let's pretend we have two arrays, two 1D arrays of integers, and we want to make a duplicate of it, right? We want an exact copy. We want to have two arrays that are exactly the same. That's the premise of what we're doing. And boy, it's raining really hard, so I don't know if you can hear that on the microphone, but that's the rain hitting the window, yeah? All right. Let's take a look at the wrong way. Okay, so we have public void copy array version 1. And we pass it an array of integers. And we pass it another array of integers. And we're just going to go ahead and hope that it makes a copy for us. All right. So let's take a look. Copy is equal to new array of integers, and it's going to be the same. Oh, okay, so hopefully you understand what's going on, yeah? It's making this copy the same length as that guy there. Well, what if this array had a length? Well, it's about to get overwritten, right? Whatever you passed it, it's making a new one right here. So we're assuming that you're not even actually using the keyword new to actually make anything at the moment. Okay, the rain has died down. Hopefully we're good now. All right, so we have stuff that's already inside here. There's nothing inside here. There's nothing in memory has actually even been created. But not to worry. The server is going to take care of that right here. New, and it's going to be the same length as that. Okay, so we use a for loop. Very logical. Let's use a for loop. We're processing it from the first item to the last item, and we're incrementing one each time, and we go ahead and say, you know what, this copy array, whatever's inside the original at that index, go ahead and also make it that in your copy. So it's one by one processing it. Seems very reasonable. Seems like it's going to make a copy. It doesn't. And you're probably going to be scratching your head and be like, well, Miss Yang, everything looks perfect to me. It does not work. Does not work. Remember, we're passing. The reason why this doesn't work is because you're passing the reference to it, and reference types are the real. It's going to actually process the real thing, right? Yes? Agreed? So this original, no matter what it was called in the client, I mean, it would have, maybe it's called my array, the 1D array of integers, maybe it was called my array in your client. When you caught it, it's caught and it's going to be nicknamed original. But it's pointing to the same place in memory as your my array. The problem is this. Okay, we passed it, hopefully a copy, a blank copy, and it really is populating that with the exact data that's inside of the original. That's really going on. But the problem is, as soon as you're done with this, the copy won't have a copy inside of it. Right? Inside your client code, you will not have a copy. So let's take a look at the client code. Let's say it's the original is called orig, and we have 1, 2, 3, 4, 5. When we pass it, it's re-nicknamed, caught as original. And we have another bookmark called CP, and that's going to be sent to this guy, and it's going to be renamed copied. It's going to be nicknamed copy inside the server, but the real name of it out here is CP. Okay, so here's the usage. We have that. We have this. We have everything set up in our client code. And let's take a look here. We call on copy array version 1. We pass it orig. we pass it CP, and it's caught and re-nickname original and copy. Okay. The array CP does not change. It stays empty. The contents of array CP is 0, 0, 0, 0, 0. Oh, that is a mistake. Ooh, I'm going to have to fix this. Sorry. Yeah, no. It's not even empty. It's not pointing to nothing. Sorry. Array CP doesn't change. It's not even empty. It's not pointing to anything in memory. It's just a bookmark not inside of a book. It's not pointing to anything at all. Now, copy, however, is, look at that, in the server code. Copy is actually pointing to something. We created something right there, and we filled it up with stuff right there. So copy is actually pointing to stuff. But it's about to be thrown away by the garbage collector, because as soon as you exit out of here, copy is gone. Copy only existed for the instance, for the lifetime of when this server code was being executed. But once you're done executing it, control goes back to the client, and copy's gone, vanished forever. So copy had a copy of the original, but then it's going to get scooped up by the garbage collector. It was never linked together with CP. Does that make sense? Right? CP is going to stay nothing, not pointing to nothing. Right? Now here's another thing that you should understand this. Here's another thing that students try to do. Oh, easy. Let me copy that array. CP equals orig. See? CP equals orig. There, I have a copy. No, you don't, right? You understand why, right? I taught you this already. You have two bookmarks in the same page of your book. There's only there's only that one place in memory with that array, but you now have two bookmarks to that same one place. So you don't have a copy there either. So also wrong. Now we have two bookmarks to the same one array in memory. Okay, so I hope you understand why this seemingly does work, and it does do work, but it doesn't actually make you a copy. It does not work when the client calls it. Nothing actually happens. Okay. At this point, CP and orig are both pointing to the same array in memory with contents 1, 2, 3, 4, 5. Yep, you understand that. If I go ahead and call on orig at point 0 and index 0, and then I say it's 9, orig is now going to be 9, 2, 3, 4, 5. And if I print it out, it'll print out 9. If I print out CP at 0, it'll also print out to 9. Because CP and orig, that's just all to illustrate really quickly and briefly. That CP and orig, if I did this, they're pointing to the same place, that same array in memory. Okay. Since CP is supposed to be a copy of orig, we expected 1 to print out if we did that. But since CP is not a genuine copy, but a bookmark to the same memory location as orig, 9 prints out instead. So yes, I hope that makes sense, right? That's the easy thing. Okay, so why don't we now look at how to copy the array the right way. So we have two arrays and we want to copy it. So let's take a look at the right way. Let's take a look at, the first line of the server code. Okay, public int, yeah. So far, so far so good, kind of. Ooh, copy array version 2, and we have just the original. What happened to the copy? Okay, look again. There's a big, big important difference between this signature of the second version, where we only have one parameter, and the return type is of type array of integers, a 1D array of integers, versus this, where the return type is nothing, it doesn't return anything, and you pass it to arrays. This is the wrong way again, and this is the right way. So, take a look. Pause the video if you need to. There's almost nothing different. We go ahead and make a copy just like we did before, and of size, the same size as the original. We do a for loop, same. So far, everything's been the same as what we've done in the first version. Here's the difference. When you hand back a copy, inside this server, we've created an array. We've populated the array with a copy of the original. And now we're going to hand back the bookmark for it. So, this thing called copy is pointing to the right place in memory with our new copy of it. So then you have to hand it back to your client so that the client can be like, oh, okay, now I have access to it too. That is the right way. There's a big, big difference. So even the usage in the client code is way different now. So here we go. Look at this. Same as before, we have orig 1, 2, 3, 4, 5. We go ahead and say int copied. We don't even need to go ahead and say new. Again, we've talked about this. You don't need it because new is going to happen inside the server. So you don't need to also do it out here. It's just a waste of memory, and it's just going to get thrown away anyways. Look at this. We go ahead and say cp equals, hey, make me a copy of the original. So the usage is very different in the client code too versus the wrong way of doing it, where you passed it both arrays. No, you don't pass it both arrays. You just pass it the original. It makes a new one and hands you back the bookmark to the new one that it created. That's what's going on here. So now CP is a genuine copy of the array orig. Now we have two arrays in memory instead of having one array in memory with two bookmarks, right? We actually have two independent separate arrays. All right, that is the end of 9.9. Homework. Let's take a look at your homework real quick and make sure that it is easy enough to understand. Ooh, I'll actually get my document camera on. Let's take a look here. Document camera. Okay. Question number 1. What happens when one uses the assignment operator equal with two array variables? In other words, it's asking you what happens, excuse me. It's asking you what happens if you, here, I'll just, here. It's easier if I just show you. What happens when you use the equal sign with two arrays like that? That is what the question is asking there. Okay? Because that's kind of hard the way they worded it. It's a little bit, it could be confusing. Question number 2. Discuss the issues involved with copying an array. I spent most of my time talking about that. So what issue can you have when you try to copy an array and it doesn't work? Write a method that returns the average of the numbers in an array of double. So you're going to write the client code, a method that gives you back the average of all the doubles in an array of doubles. Question number 4. Write a method subarray that expects an array of integers and 2 integers as parameters. So one array of integers and 2 integers as parameters. So it's expecting 3 things. Sorry, my camera's over here. It's expecting 3 things. Okay? 2 integers and 1 array of integers. The integers represent the starting position and the ending position of a subarray within the parameter array. Right? So it's a starting position, so it's not going to grab everything in it. So you have an array of 100 items. Well, you know what? I just want a subarray. I want everything between, index 20 and index 44. Right? That's what a subarray would be called, right? So that's why you need a starting position and an ending index position. That's what those 2 parameters are talking about. That's what they represent. The method should return a new array that contains the elements from the starting position to the ending position. So I want a brand new array with everything from the starting to everything to the ending. So create a new one and do it right. Make sure you copy it the right way, not the wrong way. Question number 5. Write a method that searches a 2-dimensional array for a given integer. This method should return an object of class point, which contains a row and a column. The constructor for point is point, an integer, an integer. Ooh, okay, now this one, question number 4 can be a little bit hard. Hopefully you understand it, and hopefully you do it correctly, not the wrong way. Question number 5 is very, very easy, but lots of students think it's very hard and get the question wrong. Ms. Sheng, what is point? That's an object that you're actually going to create. You have to actually create an object of type point. Just like you create an object of type student. You're actually making, well, why do I have to do that? Because this thing needs to return 2 things. A row and column. A row and column. And there's no way for a method to return 2 things. You can, remember, methods, you can only return 1 thing, whether it's 1 integer or 1 student or 1 array or 1 2D array. You can always only return 1 thing. So basically what this thing is asking you to do is you're going to have to create, you're going to have to return a point. And a point is consisted of 2 integers. Just like a student is, in our example in our book, our basic example, a student is only made up of a name and 3 test scores. That's it. All a student is a name and 3 test scores. So a point is just 2 integers, which is going to be its row and column. So let me just read this question again. Write a method that searches the 2D array. Right? So you have to write a method. You pass it a 2D array. It searches for... Oh, sorry. No, you're going to have to pass this method 2 things. You're going to have to pass it a 2D array, and you're going to have to pass it an integer that you're searching for. So let's say you're searching for the number 13 inside this 2D array. This method should return an object of class point, which contains a row and a column. So in other words, it's going to return a point that is the coordinate to where it found the number 13 inside your 2D array. So if it found it at index, row 3, column 7, well then it's going to return 0.3, 7. Right? So that's what it's going to do. So guess what? Okay, so I've given it all to you. I don't care what you name this method, name it something. But it's the parameters, it's going to receive a 2D array and one integer that you're searching for, right, the target that you're searching for. The return type is of type point, right? And all you have to, you don't have to write the client code. So good news, you don't actually have to, actually write out all the code for point, the object point, the class point. You actually just pretend it already exists. Pretend point already exists. Just make use of it properly is all you have to do. Okay, that's it. Good luck. Homework, let's see here. It is already Thursday night. So please, I would say the easiest way to submit your homework to me is write it down on paper as you always do. And you are just going to go ahead and take a picture of it with your cell phone and email it to me. Okay? So the homework, let's just say, will be due, well, it's almost midnight tonight. We'll just say Friday, let's just say Friday, 11:59 p.m. All right, that's it. Feel free to email me if you have any questions. The video ends right here. God bless. See you later. Bye-bye.